Hello, in this video we will talk about total probability and its examples. So first we will introduce what is total probability. So if we let E and F be two events, and if we want to know the event of E, and we cannot directly know what is the probability of E, but we know the conditional probability or the information of E and F, and when E and F both occurs or when E occur but F not occur. So FC is the complement of F events. So this is the union. So here means if you want to know the E, then we can know the information from EF plus the information of EFC. And EF means both E and F occur. And using conditional probability, so we can write PEF equals PF times PE given F. So this is the conditional probability of E given F occurs. And similarly, probability of E and FC equals probability of FC times probability of E given FC. So this is the conditional probability of E if F not occurs. And FC equals 1 minus probability of F. So here very interesting. So the probability of E can be given from the information of another event F and the information of conditional probability of E given F or given not F, right? So this is called the total probability function. And this is the case of only two events in F. So only F occurs and F not occurs. So we can generalize if F can be seen as multiple events. For example, F1, F2, F3. So we can write probability of E given F1 times probability F1 plus probability of E given F2 times probability of F2, then plus probability of E given F3 times probability of F3 and so on. So this is the total probability equation. Then next we show an example. An insurance company believes that people can be divided into two classes, those that are accident prone and those are not accident prone. And the statistics show that accident prone person will have an accident at some time within a fixed 1 year period with probability 0.4, whereas this probability decreases to 0.2 for a non-accident prone person. So if we assume that 30% of the population is accident prone, so what is the probability that a new policyholder will have an accident within a year of purchasing a policy? So here, if we want to know a new policyholder, so this is the person and we want to know the probability that he will have an accident in a year of purchasing a policy. So this is like the probability of E in the previous equation. And we know the information of another event, so which is the person is accident prone or not. So we also know the ratio of the person who is accident prone or not, 0.3%, 30% and 70%. And if the person belongs to the probability accident prone, then he will have accident probability 0.4 in the next year. So this is the conditional probability of he is accident prone, right? Then from this idea, so we can write probability A1 denotes the event that the policyholder will have an accident within a year of purchase, and this is what we want to know. And we let A denote the event that the policyholder is accident prone or not. So because we do not know this person belongs to the accident prone or not, but we know the total population, the ratio is 0.3 for the accident prone person. So this is the probability of A and the probability of AC. So PA is 0.3 and PC is 0.7. So if the person belongs to PA, then the conditional probability of A1 given A is 0.4 because we want to calculate A1, but we have the information of A, which is the person belong to the accident prone or not. So this is the total probability. We divided two cases. One case is he is accident prone, and another case is he's not accident prone, right? So if he is accident prone, then the conditional probability of he will have accident given he is accident prone is 0.4. And if he is not accident prone, then the probability of he will have accident given he is not accident prone is 0.2. Then we multiply these together, then summation. So the total probability is 0.26 for A1. So which means we just pick a person and we can calculate the average probability of this person will have accident in the next year is 0.26. Thanks for watching.